Well, good evening, everyone. I think we're ready to start, so we might stand up for a prayer. In the name of the Father, and the Son, and the Holy Spirit, one God. Amen. We thank you, God, for bringing us to the end of another week, for bringing us together in your house. May you guide us and illuminate our minds and our hearts with your love and your truth. Through the intercessions of Saint Mary and Pope Carolus VI and all your saints and angels, hear us as we pray together. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil. Through Jesus Christ our Lord, for thine is the kingdom, power and glory, forever and ever. Amen. Okay, so if you can, we're going to switch all the lights off. I hope nobody's scared of the dark. But that's just to help us to get into the mood for our topic tonight, which is, I think it was advertised as the fingerprint of God. So basically what we're going to be doing is we're going to be looking at the heavens. Let me just see if I can get this working. There we go. So the alternative title is A Night in... Yeah, if you can switch that off, that'd be great. Excellent. Oh, great. We have atmosphere going here. Yes. We're going to spend a night in the second heaven. What is the second heaven? What are we talking about? Well, in olden times, people used to speak of 3 heavens at least, and sometimes people would add a 4th. So the first heaven was basically the atmosphere of the earth, where the air is and the birds fly and stuff like that, and the trees grow up into it. And the second heaven is what we would today call outer space, beyond the atmosphere of the earth, so the place where the moon and the stars and the planets and so on, that was called the second heaven, as far as you can see. And then the third heaven, which in many sort of models of the universe was outside the second heaven. So you had the sphere of the stars, which was like a great big ball. And what was beyond that, well, that's where you'd find the third heaven. That's where the angels live, and that's where God is, and so on. And some people would say we should also add a 4th heaven in addition to those 3, which is just the place where God himself exists, nothing else. But so that's why basically today I'm talking about the second heaven. It's just an old name for what we today would call the universe, space, the final frontier. These are the... No, we won't go into that. And we find that the heavens are often mentioned in the Bible. They're mentioned in the Mass. They're mentioned in Tasbihah and praises. And I've just got a couple of verses here. So the Psalms talk about the heavens. The heavens declare the glory of God, and the firmament shows his handiwork. So sorry, I'm just going to sit down. Since it's dark, nobody can see me. And you're all looking at the screen. Often when the heavens are mentioned in the Bible, it's as a pointer to the glory of God. It's as a reflection of who God is and how God put some of his wisdom and his beauty and his intelligence, I suppose we could say, his design into the heavens and made them so vast, so majestic, and also so beautiful. And we find in the New Testament, St. Paul also says, "For since the creation of the world, his invisible attributes are clearly seen, being understood by the things that are made." So you get what St. Paul is saying here. He's pointing out that when you look at the physical universe that God has created, you can actually know something about the invisible God who created it. I suppose that's a bit like when you look at a beautiful painting. You can tell a little bit about the artist who painted it. If it has lots of very soft colours and gentle curves and things like that, then you might think he's a gentle sort of person. If it's very violent with bright reds and oranges and things, you might think he's a bit excitable or something like that. So we look at the heavens and we kind of get an idea of the essence of God that went in behind it. So let's start our little tour of the second heaven and see what we can find out about God through it. So the first place to start is when you look up at the sky, you see lots of dots of light. You see lots of stars. In ancient times, some people thought that basically there was this huge solid sphere and there were holes in the sphere. And the light of heaven was shining through those holes, and that's what a star was. It was like a hole through which the light is shining. But of course, some people realized that that couldn't be the case because some of those points of light were actually moving against the other points of light. That would seem really weird that a hole is moving from night to night. That seems odd. So even in ancient times, other people still also realized that they're probably actually just some kind of source of light. And they may have talked about whether they're like thinking creatures. Some people thought the stars were thinking creatures. Some people thought that when people die on earth, they go up and become a star in the second heaven and things like that. But one of the things that pretty much everybody did who looked up at the stars is they saw patterns in the stars. And they exercised our human delight in organising things. So they decided to join the dots, literally join the dots, and call groups of stars what we today call constellations, which just comes from the word for a star. That's the stellations bit, and con meaning together. So in other words, it just means stars together, groups of stars together. And they're very useful. Having these constellations is very useful because it helps you kind of navigate and know which part of the sky it is that you're looking at. Today we have 88 modern constellations, including 48 which are ancient constellations. And there were some ancient and even medieval constellations that people introduced but then eventually got dropped. Today there's like a body called something like the International Astronomical Union who's sort of responsible for deciding what's a constellation, what isn't, and where the borders are and stuff like that. It is very important to realize though that just because we see two stars next to each other doesn't mean that they are actually physically next to each other. Sometimes you can be looking at two stars that are really close and one of them is 100 times further from us than the other one. But they just happen to be in the same direction, so they look like they're next to each other. And the brightness of a star doesn't immediately tell you whether it's near or far. Of course, if something is further, it's less bright. But if you have a really, really bright star that's far away and a very dim star that's nearby, they may look the same brightness to us from the point of view of Earth. Another interesting thing is that the constellations that we use is only one way that you can divide up the sky. And in fact, different cultures today and throughout history have divided up the sky in different ways. And we're actually going to look at one of the variations on that. But there's lots of, like the Babylonians had a way of doing it, which actually is kind of the forerunner of the way that we do it today. We inherited that through the Greeks, who inherited from the Babylonians. But you have like, Native American and South American and Inca constellations and African constellations and Aboriginal constellations, which are really cool. In the Aboriginal system, there's the Great Emu, which is really cool. I don't think I've got a picture of it, unfortunately, but it's nice to know that there's an emu in the sky, because emus don't get to fly. They don't have wings. So isn't it nice that there's at least one emu that's up there in the sky? Okay, so here is an example of a constellation, one of the more obvious ones. Some constellations look like the thing they're meant to. Some constellations, you really have to use your imagination because they don't look like it. This one kind of is halfway, kind of looks like it. Orion is the hunter. Can anyone see the hunter there? There's a few lines that help you a little bit. They don't help you that much. But let me help you a little bit more. That's his head, right? So the star underneath that circle is his shoulder. And that's his arm, right? So the star at the end of his arm, that's his hand. And what is he doing? He's a hunter. So he's using a bow, an arrow. That's his bow. You see sort of that arc of stars that make that red line traces? Is that making sense or not really? Yeah? And then that's his belt, because every good hunter needs a belt. Why do you need a belt? You need to hang your sword, right? So the three bright stars are his belt, and then that little line of stars down there is the sword. And then the two bright stars at the bottom are his, well, I don't know if they're his feet or his knees. You can make up your mind there. Very short legs if they're his feet. Okay, so, and of course Orion is mentioned in the book of Job. Can you bind the cluster of the Pleiades or loose the belt of Orion? So when you read that in the Bible, this is what he's talking about. Those three really bright stars that make up the belt of Orion. And this is a constellation that looks a little bit more obviously like what it's meant to represent. In this picture, and by the way, the sky doesn't look like this when you go out and look at it, particularly if you're in Mount Druitt, because we have a lot of bright lights everywhere. So you don't see the cloud of background stars. If you want to see those, you need to go out into the bush, far away from any towns or cities where there's no light pollution. And then on a good clear night, if you look up, you don't see that much, but you do see the Milky Way. It's actually really impressive and quite astounding when you look up and you see it. But here is Scorpius. That's joining the dots. So if you can see between every yellow line there is a star. Can you kind of see that? See the stars? And can you kind of see the scorpion shape? So at the top of the screen there, you've got the tail of the scorpion, which arches over its back, right? At the bottom, you've got the T kind of thing, which is the claws of the scorpion. So they're the two claws, the two bright stars at the end of that line. At the either end of that line are the two claws of the scorpion. And if you just see where the blue word Scorpius is and go left, you'll see there's a bright reddish star just to the left of it near that yellow line. It's brighter than most of the other stars around it. And that's called the heart of the scorpion. And it's reddish, so it looks like a heart. And it's actually, its proper name is Antares because it looks like Mars, which also has the name of Aries. So it's anti-Aries. It's the star which is the opposite of Aries or against Aries. And that's because Mars sometimes actually comes right up close to that star. And they look very similar. So this star, Antares, is the star which is opposite Aries, opposite Mars. And it looks like Mars as well. And at the end of the tail of a scorpion, what do you have? You have a sting. So can you see the little sting there? See how the line ends with one bright star, but then there's another little bright star at an angle? Just in case you can't see it, there it is there for you. See the sting. Okay, so there's some of the constellations. You'll notice that some of them could be pretty old, things like the scorpion and the hunter and the big dog and the little dog and so on. Some of them are more recent. They didn't have telescopes back in ancient times, so that's one of the new ones. They didn't know about Indians. Today that might be considered a little bit racist, but I haven't heard that anyone's talking about changing it. And remember I said that different cultures have had different ways to group the stars and to organise the constellations. There was one fellow in the 17th century who decided we need some good Christian constellations. So he came up with his own way, his own system for naming the stars and organising them. And basically he replaced the pagan constellations that go all the way back to the Babylonian times with biblical and early Christian figures. So you know the zodiac, the 12 signs of the zodiac, Scorpius and Libra and Virgo and so on. He replaced those with the 12 apostles. So instead of them, you had Matthew and John and James and Andrew and so on. And he replaced the constellations in the northern hemisphere with figures from the New Testament and those in the southern hemisphere with figures from the Old Testament. And obviously he lived in Europe, Julius Schiller being his name, from Germany. So he seemed to obviously want to keep the New Testament close to him, and he wasn't that worried about the Old Testament for some reason. And he also replaced the planets and the sun and the moon with biblical figures, gave them names of biblical figures. So here is one example. This is what we normally call lyra, which is a lyre, like a harp. It's meant to be a harp. But he said, no, this is the manger of Christ. We're going to call this the manger of Christ. And so here is his diagram from the 17th century. So all of those black dots are the stars, and the ones in the manger are the stars of Lyra. I don't know if you can see that. And I don't know if my shiny thing shines on the screen. Let me see. It doesn't. Oh, it is working. Yeah. Okay, so remember there was those 4 stars. There's 1, 2, 3, 4, and then the handle of the lyre up the top. It's sort of a mirror image here because in the map he's drawn it as a mirror image. But that's the lyre, and he's drawn around it the manger. And can you guess the constellations near that constellation? What's on the left there? Can you guess who they are? Who would be at the manger of Christ? Who is it? The 3 wise men, yeah, the Magi. And who do you think that is on the right? A nice lady with a crown. It's got to be St. Mary, of course. So isn't that nice? So if you really want to have a Christian experience looking at the stars, find Schiller's Atlas, and then you can go out and find the 12 apostles and St. Mary and the manger and, church fathers and all sorts of things. So what's actually going on when we look at constellations and see these pictures in the sky? Basically what we're doing is joining the dots. And nowadays they'd call that pattern recognition. So our brains are kind of built to see patterns in things. Where there are only dots, our brains put the dots together and make patterns. And that's how we end up with constellations, and that's what we've been doing for millennia. That's what human beings have been doing forever. Since they, once they realized there were stars up there and looked at them, they started seeing patterns and calling them names and so on. But some people took it a little bit further and started to extend patterns not just to seeing shapes in the sky, but to seeing patterns of influence, and started thinking maybe the stars are influencing what happens down on Earth. And this led to the development of what we call astrology. So people who read their horoscope I'm a Libra. What's going to happen to me today? Let me find out on my horoscope. That's a kind of astrology. Another kind is to look at where the stars were and how the planets were aligned on the day that you were born. And then from that, a capable astrologer could predict what kind of life you were going to have. Are you going to be successful or not? And that sort of thing. And astrology was taken, and we shouldn't confuse astrology, which is that kind of pattern recognition on steroids, finding all these connections with things happening down here and the stars up there. We mustn't confuse that with astronomy, which is the modern science of astronomy, which basically looks at what's up there, stars and gases and nebula and the physics of it and that kind of thing. But for most of history, astrology was taken very, very seriously, even by the most educated and well-known, people who are famous for their philosophy and so on. Some church fathers even discussed it, but some church fathers rejected it, and they rejected it really for very sensible reasons. So St. Augustine, for example, has a passage where he says, okay, those astrologers say that you can look at where the stars and the planets were when someone is born, and you can therefore predict their life, what's going to happen in their life. What happens when twins are born? They're born at exactly the same time, under the same stars, in the same positions. And yet, when you look at the lives of twins, very often they have very different lives. One may get married, the other may not. One may have a job, the other may not. One may stay here, the other may live in a different country. So he actually just, by thinking about it, reasoned really good reasons for thinking that astrology doesn't work. You can't predict what's going on. The stars don't determine what happens to us. It just doesn't work. And I think that's pretty good for 1,600 years ago. And it's kind of the same reason that modern science sort of rejects astrology today. Okay, here's a little quiz. I have a few questions for you. The idea here being just to give you an idea of how big the universe is. Because if I ask you, is the universe big? You'll say yes. But we have a lot of trouble actually grasping just how big it is. So, first question, what is a light year? Feel free to call out the answer. Yes, the distance that light travels in exactly 1 year. And, I should have asked you this before I clicked it up. How many kilometres is that? It's a lot, because light travels at 300,000 kilometres per second, right? To give you an idea of how big that is, think of the whole planet Earth, line up 10 planet Earths in a line, that's roughly 300,000 kilometres. So light travels in 1 second, the time it takes you to say 1 potato. Okay, in that time, light can travel from the beginning of the first Earth to the end of the 10th Earth. Okay, that's pretty big. That's a light second. You have to multiply that by the number of seconds there are in a year, which is 31,556,736 seconds every year. So multiply 300,000 by 31 million, and that gives you how many kilometres is a light year. It's big, right? It's huge. It's an awfully big thing. Can we travel faster than light? Okay, someone said not yet. Most people would argue that that's the wrong answer. The answer is no. It's actually impossible. And there are reasons why it's impossible. Because as you get closer and closer to the speed of light, according to Einstein's relativity, your mass increases, how much you weigh. And your mass increases exponentially. So that means that if you were to get to the speed of light, your mass would become infinite. And that seems to be impossible. So it seems that we can't travel faster than the speed of light. But now that I've said that, next week someone's probably going to come up with some way that we actually can. Okay, how far away are the sun and the moon? So one way to think about that is how much time does the light take to travel from the sun or from the moon? Which one is closer, the moon or the sun? The moon. That's very, very good. Okay, so it's about 1.3 seconds. That's how long it takes light to travel from the moon to the Earth. 8 minutes, 8 light minutes is the distance between us and the sun. So that's pretty huge, okay? That's a very large distance. How far is the nearest star? Yeah, well, Proxima Centauri is apparently, it is moving, so, and this is a bit old, so maybe that figure is out of date, but roughly 4.3 light years to the nearest star. And an interesting piece of news not that long ago, they discovered that there are planets around Proxima Centauri, and that some of them are actually in the habitable zone, which is like they're not too far, not too close, like they don't get burned by the star and they're not too far to be frozen. So there may actually be liquid water on the planets around Proxima Centauri. And if that's true, then there may be life. And that's really cool because it's the closest star to us. But it's a very, very faint red dwarf, so it's actually very hard to see, unfortunately. Okay, 4.3 light years is a big distance. When you look with a telescope, you need a telescope to see it, and look at Proxima Centauri, you are not seeing Proxima Centauri as it is today. You are seeing Proxima Centauri as it was 4.3 years ago. So if the clouds open up for us and we get the telescope out tonight, one of the things you can think about as you're looking through the telescope is that you are looking through a time machine, because you are actually looking back in time. The things we'll be seeing in there are not as they are now, but as they were however many years ago when the light left them. Okay, 4.3 light years is big. How far is the nearest major galaxy? And the answer is about 2.5 million light years away. And that's the Andromeda Galaxy. That is really, really big. What is the farthest object we know of? And I did check this one to make sure I've got this up to date. I found the one that I had here the last time I gave the talk is now the 4th farthest object. The answer at the moment is the galaxy GNZ11, which is 13.39 billion light years away. That's billion, not million. Billion with a B. And what that means is the light from that galaxy left it and started its long, long journey towards us 13.39 billion years ago. But since that time, the galaxy, the universe has expanded. So today, it is actually 32 billion light years away, because it's been moving away all that time that the light has been traveling towards us. The galaxy itself has been moving away from us. So the actual distance between us is that much. Remember how big a light year was? Multiply that by 32 billion, and that seems to be the radius of the universe that exists at the moment. Double that to give you the diameter, which is 64 billion light years. Do you agree with me it's a big place? It's awfully big. So the first lesson we can learn by looking out into space is that we are very, very small. Not only are we small in the hugeness of space, we are small in the hugeness of the time, of the age of the universe. We've only been around like for a few 100,000 years maybe. Okay? The universe has been around for at least 13 billion years, probably bigger. So sometimes we think, when we're worried about all our little problems, that the whole universe revolves around us. Okay, don't you sort of think that sometimes? All the world revolves around my problems. No, it doesn't. Okay, we are tiny in this big, big universe. And I think that's a really good thing. When you look up at night and you see all those stars, it's good to remember that, and to remember to be humble, to remember that your problems are not so big. But does that mean that we should feel that we are insignificant? That we are just this little speck of dust in a cold, unloving, dark universe? No, because the Bible actually tells us that the one who made this huge, huge universe cares about us and loves us individually. And that makes the love of God even more amazing. This is from Psalm 8. When I consider your heavens, the work of your fingers, the moon and the stars which you have ordained, what is man that you are mindful of him, and the son of man that you visit him? So the psalmist got this same message. He realized the universe is really big. So what are we in this big universe? But you have made him a little lower than the angels, and you have crowned him with glory and honor. And he goes on and expresses how God has loved us, and he has honored us, and we are important to him. And that's a really comforting feeling. So we learn to be humble by looking at the stars. But when we see how small we are, and then we think about how much God still loves us and cares for us, then that is what gives us our sense of self-worth. And we realize that being loved by God is enough to make us something that matters in this big, big universe. Okay, how many stars are there in the universe? And if you want to say a gazillion, you'd be pretty close. So there are, I don't think there's a name for this number. There's roughly 100,000 million, 100 billion galaxies, each of which on average have 100 billion stars. So you have to multiply the number of stars by the number of galaxies, and that gives you 10 to the power of 22 stars. So that is a 1 with 22 zeros after it. Each of those stars is like our sun. Some of them are smaller, some of them are bigger, but that's what we're talking about when we talk about a star. And probably we're starting to think now maybe the majority of them have planetary systems going around them, and so on. Okay, here's a good trivia question. You know, in the Bible, God promises to Abraham that he'll make his descendants as the stars of the heavens and as the sands of the seashore. Which number is bigger? Are there more grains of sand on all the beaches of the earth, or are there more stars in the universe? Which one's bigger? Yeah, you can guess, can't you, what the answer is? It's actually the stars by a very, very long way. There are far more stars in the universe than there are grains of sand on the earth. Again, that just gives you an idea of how big this universe is and how big is the God who created this huge universe. However, you don't get to see 10 to the 22 stars. With your naked eye, you can see, and this is like, again, if you're not in a city or a town with lots of electric lights, you can see about 6,000 stars with the naked eye. And keep in mind, you can only see half the sky at a time. That's like for the whole sky, 360 degrees. So from any place on the earth, you can only see about 3,000 stars altogether at a time. If we were to walk out now and just look up, and if there weren't any clouds, you'd see an awful lot less than 3,000 stars because of all the light pollution and so on. If you're in like a really bright city, whenever I've been in Cairo, I always try and go out and have a look up and see what stars I can see, because it's Northern Hemisphere and they have all these different constellations and things. And depending on where you are in Cairo, because it's such a condensed city, sometimes you can only see like a dozen stars, and that's really sad. And I think in some cities in the world now, you actually can't see any stars at all at night because there's so much electric light pollution. And I think that's really sad because whole generations of people are growing up never having seen a star. Maybe they've seen a picture of it, but they've never actually looked up at the sky and seen a star. But this is how many stars there are. This is a very famous picture. It's called the Hubble Deep Field. And actually, I think they've done another one after that, which is even more amazing. So Hubble is a telescope, which is in space. It's orbiting the Earth. And because it's in space, it's far away from the atmosphere of the Earth, far away from the light pollution. So it can see really, really clearly. This is a teensy tiny little bit of the sky. I can't remember what it was exactly, but I think it's something like if you stood in Parramatta and looked at a 10-cent piece on Sydney Tower, that's how big that bit of the sky is that we're looking at. Like it's this tiny, tiny, tiny little bit of the sky. And yet, look at it, it's full of stuff. And they're not only stars. Some of them are stars which are nearby the Earth. But a lot of those dots, especially the squiggles and the fuzzy ones and the coloured ones, they're not stars, they're galaxies, each of which on average has about 100,000 million stars. So even in this one tiny little bit of the sky, look at how crowded it is. And the way they got this picture is they basically pointed the telescope at that one little bit of the sky for something like 15 days. And it was just collecting the light over 15 days, collecting, and gradually registering on its sensors and building up the signal until you see this. I could look at that forever. It's like looking into the mind of God. And just think, who knows? Maybe on 3 or 4 of those galaxies, there's someone else who's looking back at us through their telescope and thinking, I wonder if there's life on that little squiggle. And we're looking at their squiggle and saying, I wonder if there's life on that little squiggle. So our second lesson is that God is in control. You don't need astrology to tell you what your future is. Your future is God loves you. And he's looking after you, and he cares for you. And you can learn that from the stars, but not by reading the stars as in astrology. You can learn that by reading the love of God who made those stars for us to enjoy. If he can create and run such a huge universe like this, he can certainly cope with our little problems in our lives. And I always find it very, very comforting when you're going through difficulties and problems and you look up and you see the stars and you realize that nothing that we human beings do on earth can ever change what's going on up there. They will still be themselves. They will still follow their paths. Even if we all got nuclear bombs and blew up the whole planet, it would have zero effect on anything else in the universe. Everything else, except the moon, maybe. But apart from that, everything else would just continue to run. And I find a sense of comfort in that. It reminds me of the God who is the stable rock on which we can build our lives. And no matter what happens in our lives, things come and go, problems come and go, but God never changes. He's always there. Again from the Psalms, the Lord is your keeper, the Lord is your shade at your right hand. The sun shall not strike you by day, nor the moon by night. The Lord shall preserve you from all evil. He shall preserve your soul. Okay, let's go back in history a little bit and look at a couple of big ideas that people had about this big universe and what they can teach us, because there are some very good lessons to be learned. So this handsome fellow is a statue of Ptolemy, who was an Alexandrian, although he was of Greek origin, but he lived in Alexandria and he worked in Alexandria, and he was like the top astronomer of the ancient world. And he was so influential that up until the 17th century probably, people still followed his system and his understanding of the universe. And basically, his understanding was the Earth is at the center of the universe. The Earth stands still. The Earth never moves. How do you know that? Well, do you feel like you're moving at the moment? Does it feel like you're moving? Of course it doesn't. Therefore, the Earth must be standing still. When you look at the sky, does the sun feel like it's moving? Does the moon feel like it's moving? Do the stars? The answer is yes. If you stand there for long enough, you'll see that they seem to be moving in the sky. So he just extrapolated from that. Actually, it wasn't him. Other people did it before him. That the Earth stands still and the stars are like spheres in a big sphere that slowly rotates around the Earth, and then you've got other spheres in which you have the planets and the moon and the sun, and they all rotate around the Earth. And this would be fine until you start actually measuring the position of where the stars and the planets and the things are. And then you find it doesn't actually match up. So you'll notice on his final sort of model there, he actually doesn't have the Earth exactly in the center. He has it out to one side. And that's to try and match up with the measurements of where the stars are, because the Earth actually goes around the sun, we now know, and because of that, the stars actually shift, like between winter and summer, they shift slightly in where they are in the sky. But that was because he had to keep the Earth standing still, so he just moved it a little bit from the center. And then those other lovely squiggles are because sometimes planets like Mars and Jupiter, like as you follow them over the months, They move across the background of the sky, of the other stars, and then they stop, and then over a few more weeks they go backwards against the background of the stars, and then they stop, and then for another few weeks they start going back in the same direction again. That seems really weird. How are they doing that? His solution was that. I take the sphere, which is the big circle, and then I make a little circle around a point on that big circle, and that's where the planet goes. So when the planet is sort of at the bottom of the little circle, it's going backwards. When it's at the top of the little circle, it's going forwards, if they're going anti-clockwise around. Okay. Now, you can see he's really having to tweak his model, and really do some gymnastics here, geometrical gymnastics, just to make it match up with what you observe. But it actually turns out there's a much simpler way to do it. And this was the fellow who came up with the simpler way to do it. This is Nicholas Copernicus, who, may I point out, was a priest in the Catholic Church. And he came up with the idea that we could solve all of these measurement problems. We could come up with a model that fits so much better if we simply move the Earth away from the middle and put it as one of the planets and put the sun in the middle. It seems like such a simple, obvious idea. But people wanted to put him in prison for it. He actually didn't publish it until, I think, really late in his life, just before he died, because he was afraid of what people would do to him if he said it. And it solves the problem. So, for example, why does Mars or Jupiter seem to go backwards? Well, it's the same as if you're on a train and you're passing another train going in the same direction, but that's going slower than you. When you look out the window, the slower train looks as if it's going backwards as you pass it. And that's what's happening. As the Earth goes past Jupiter, because we're going faster than the Mars or Jupiter, it looks for a little while as if Mars or Jupiter are going backwards relative to the background. And that solves it really simply. You don't need all these little circles within circles within circles. You don't need any of that stuff. Here is a quote from Cardinal Bellarmine in 1615. This is when Galileo started espousing Copernicus's model and developing it, and he got into a bit of trouble. And this is what one of the big wigs in the Catholic Church at the time said: "To affirm that the sun is really fixed in the centre of the heavens and that the earth revolves very swiftly around the sun is a dangerous thing, not only irritating the theologians and the philosophers, but injuring our holy faith and making sacred scripture false." What do you think about that? What's he saying here? He's saying if you say that the sun is in the middle of the universe and the earth goes around it, you're making the Bible wrong. Because the Bible says that the earth is the center of the universe. Does it? Show me the verse where the Bible says the earth is the center of the universe. It actually doesn't. The Bible says things like, the circle of the sun as it moves. But all it's doing, it's not giving us a scientific model of the universe. The Bible is simply describing what the sun looks like when you're standing on the surface of the earth. What theologians and philosophers had done for all of those years is read way more into the Bible than was really there. And they forgot the difference between what the Bible is actually saying and what they interpreted the Bible to be saying. They confuse the two things together. So when this new model comes up and it clashes with their interpretation of the Bible, they think that it's against the Bible itself. And that's a big mistake. So that's a really good thing to avoid. I'm telling you this story because it's a really important thing for us today, with all the scientific knowledge that we have today, to be really careful that we don't think that it goes against the Bible when it's actually just going against our interpretation of the Bible. And then there's the whole Big Bang thing. So there are still Christians around today who think that the Big Bang is against the Bible. But thankfully, the vast majority of Christians today actually see it as agreeing with the Bible, because what are the very first words in the Bible? In the book of Genesis, in the beginning, God created the heavens and the earth, right? And that's interesting because there were philosophers in ancient times like Aristotle who believe that the universe is eternal. It has no beginning. And then in the early half of the 20th century, there were two big sort of theories around. One, that the universe has a beginning, and the other one was called the steady state theory, that says, like Aristotle, that the universe has no beginning. It's just been as it is forever. Sure, maybe a few stars move here and a few stars move there, but basically it's just been the way it is generally forever and ever and ever. And if you say that, you kind of say, well, then why do we need God? The universe just exists. That's actually not a good argument, but we won't go into that now, because you still need someone to create an eternal universe. But if the universe had a beginning, then you really can't escape the idea that something has to begin it. Something has to be the reason why it begins. And so a lot of scientists were actually very strongly against the Big Bang theory. They didn't like the idea that the universe has to have a beginning. But it ended up winning over the steady state theory, and completely so, because the evidence for the Big Bang theory makes it one of the most well-evidenced theories there are in science today. And the story of the Big Bang theory is actually quite interesting. It begins with a guy who nobody ever mentions anymore. The poor guy's been completely forgotten. A guy with the delightful name of Vesto Slipher. And he was the one who measured the redshifts in the distant galaxies. So he sat there at his telescope, painstakingly looking at the spectrum of the light coming from different galaxies. And he realized that the farther away a galaxy is from us, the more the light of it is shifted towards the red end of the spectrum. So if you haven't come across this idea before, think of trains again. If you're standing on the platform and an express train is going through your station, this is what you hear, something like this. Okay, what's the difference there? It was a high pitch as it was coming towards you, and then it goes into a low pitch as it goes away from you. And that's because sound waves are coming from the train, and every time the train sends off a sound wave and then moves another 100 meters and sends off the next sound wave, so what happens to the waves? They're actually closer together, so it's a higher frequency. It's a high frequency. And then as it's moving away from you, the reverse thing happens. It sends off a sound wave back towards you, then it moves 100 meters away from you before it sends off the next one. So now the waves are further apart, which makes it a low frequency. So now it's going, right? And you can do that with light as well. Light is waves. So if a star or a galaxy is moving towards you, the frequency increases, which means it goes towards the blue end of the spectrum. And if it's moving away from you, the frequency decreases, and therefore it goes towards the red end of the spectrum. And it turns out that our galaxy, our planet, seems to have a really bad case of body odor because the rest of the universe is running away from us as fast as they can. And the further away they are from us, the faster they're going away. And then another priest. This is why I like astronomy. Priests are everywhere. Called Father Georges Lemaitre, who was a Belgian Catholic priest and a professor of astronomy. He was the first person to come up with this theory that if the whole universe is expanding, then if you play that back in time, like playing a video back in time, then it's going to contract and contract and contract, and it must have started as a single point. He called it the cosmic egg, which I really wish would have caught on, because I really would have loved to be talking about the cosmic egg theory. That would just sound so cool. The cosmic egg. Doesn't that sort of just sound mysterious and wonderful? But unfortunately, that name didn't catch on. A couple of years later, another astronomer called Edwin Hubble, who now is really, really famous, came up with the Hubble constant, which sort of puts a mathematical equation to this redshift and so on. And he became sort of really famous as the originator of this theory. And the name Big Bang actually came from someone who didn't like it. And he coined that term as a way to sort of make fun of this theory. Oh, you believe in a Big Bang, do you? You think that that's how the universe started. And the name caught on, and that's what we call it now. So it's amazing to think that before these three guys, people looked and they saw things like this in telescopes. They saw things like this cloud of stars there. And they thought that that was just like something within our galaxy. They thought there was only one galaxy, and that was the whole universe. And it's only once they started measuring these redshifts and stuff that they started, and other factors, other tests that they did, other things that they did, made them realize that we're actually not the only galaxy, but there are other galaxies like ours, and that they're moving away from us. And so this is the sort of the more or less modern view of the Big Bang. So time goes from left to right here, and it starts with this single point. We have no idea what it is. Well, Christians have an idea, because we would say that's how God created the universe, but scientifically we have no idea what it is. And there's this huge inflationary period at the beginning where everything just gets big really, really fast. And then it slows down a little bit, and then all of the matter starts to separate, so light begins to be able to flow, and then you start getting stuff sticking together and making planets and galaxies and stars and so on, until here we are today, 13.85 billion years later. And the really interesting thing they discovered about 15 or 20 years ago is that normally when an explosion happens, things are moving away from each other really fast at the beginning, and as they get further away, they slow down, right? But that's because of friction. If there was no friction, you'd just expect them to keep moving at the same speed away from each other. But it turns out that as time has gone on, you'll notice that that cone is now actually speeding up in its expansion. And that's why they've started bringing in things like dark energy to explain. So dark energy seems to be this mysterious thing that does the opposite of what gravity does. Gravity makes things want to stick together. Dark energy makes things want to fly apart. And it seems the balance between the two is tipping, so that dark energy is becoming more influential than gravity. And the universe is speeding up. So up until they made that discovery, they thought that maybe, possibly, eventually the universe would like slow down and slow down and slow down, stop, and then start coming back again, and then the universe would end in a big crunch. Right? Everything would crunch together. We now know that that's highly unlikely, because it's actually speeding up in its expansion. So it's more likely that everything's just going to fly apart. And if that goes on like for a long enough time, then we won't even be able to see other galaxies, because they'll have flown away from us so far that we can't see them anymore. That would be sad. I'm so glad we live now. So here are some lessons to learn from the history of looking at the universe. And that is that there is a difference between what faith tells us and what science tells us, and we should be careful that we don't confuse the two. Faith gives us the meaning of our life. It tells us why we exist. Science can't do that. But science tells us how the world works, and faith doesn't want to do that, because that's not the important thing. And if we do science and faith the right way, then they actually complement each other. They give you together a more comprehensive picture of reality than you can get with either by itself. But if you do either of them wrong, then you start getting wrong conclusions and you start going wrong. So, people got really upset about the Big Bang Theory and, oh, that's not what the Bible says and so on. Okay, but I'm sorry if anyone here is from Melbourne, I apologise. So, like Melbourne's weather, if you don't like a scientific theory, just wait a few centuries. Because what we understand scientifically today is very different to what we understood even 100 years ago, or 1,000 years ago, definitely. Imagine what the science of 1,000 years from now in the future is going to look like. So let's not get too heated up about this theory or that theory. In the end, our scientific theories are changing all the time. Our faith doesn't. The meaning of our life doesn't. The importance and the centrality of the God of love in our life, that never changes. It hasn't changed through all the thousands of years, and that's not going to change. So once again from Isaiah, "For my thoughts are not your thoughts, nor are your ways my ways, says the Lord. For as the heavens are higher than the earth, so are my ways higher than your ways, and my thoughts than your thoughts." When we just think about what we're learning about the universe, and how, if there are other alien creatures somewhere that are more advanced than us, they probably think that we're really naive and don't know anything. And then you think that the knowledge of God is way beyond anything that any creature in the universe is going to be able to know or understand. Again, it makes you appreciate the majesty and the wisdom of God. Okay, this is the last bit. This is probably my favourite bit. So let's have a look at the kinds of things that are actually out there. We've spoken about how big the universe is. We've spoken about how we have evolved in our understanding of how it works. Let's now have a look at what there actually is out there. So I'm not going to read through this list, but these are the kinds of things that you find out there. So these are all just stuff in our solar system, planets and moons and asteroids and comets and meteors. And then beyond our solar system, you have stars which come in a variety of colours. If the sky clears up tonight, we actually will have a chance to look at a lovely little cluster of different colours. It's called the Jewel Box, and it's in the constellation of the Southern Cross. And it's really pretty, all the different colours, reds and oranges and greens and yellows and whites like diamonds. Very beautiful. And stars that vary and globular clusters. Again, if the sky clears up, we're actually going to have a look at a globular cluster tonight. And galaxies and galaxy clusters. And it doesn't stop there. There's these weird things called black holes. Light, the gravity of them is so strong that light can't even escape from them. So if you look at them, you can't see anything because there's no light coming from them. There's a bit of light that might come from the radiation around them, but they themselves just seem like an empty bit in space. Did you know stars can be cannibalistic? They can eat each other. Big stars can draw in little stars. And we think that at the center of most galaxies is a big, big, big black hole that has just been feasting on the stars of its galaxy for millions and billions of years. And basically it becomes huge. I think the biggest one is something like 3 million suns. Like, that's how heavy it is. It's just huge. We've talked about dark matter and dark energy and gamma ray bursters and supernovae and so on. So let's have a look at a few pictures. And I must warn you that we're going to look at pictures that look very pretty and very beautiful. Unfortunately, when you then go out and look through an actual telescope, you get really, really disappointed because you don't see the pretty colours and you don't see all the detail. The pictures we're going to look at are pictures that you get by pointing a telescope with a camera attached for like 10 hours at something, and it collects light for all that time. Our eyes don't work that way. Our eyes just take it, in real time. So you don't, things look really grey in a telescope. They look really colourful here, but in a telescope they don't look so bright. So I hope that, one, we won't be disappointed because the sky will clear, and two, I hope you won't be disappointed because it looks very small and fuzzy and grey when you see things. What's this? Any guesses? Yes, these are called star trails. So if your eyes were cameras, and if you just gaped at the sky at night for, I don't know, that's probably 3 hours, that's what you would record. Because the stars are moving, right? Actually, the stars are not moving. They look like they are. The Earth is turning. And so as the Earth turns and the stars stay where they are, they make a trail. If you have a camera sort of recording it, the dot of light turns into a curve of light as it records dot after dot after dot after dot after dot. And you can actually tell how long this exposure was by measuring the angle of each of those. So each of those arcs is one star, right? And I reckon, what's that? That's probably about 30 degrees. So 24 hours, what's 30 degrees out of? That's 1/12 of 360. So that's about 2 hours, 1/12 of 24 hours. So someone just opened the shutter on their camera and left it for 2 hours and then closed the shutter. And that's what you end up with. Isn't it pretty? What's that? Is it a volcano? There's no mountain at the bottom. Any guesses? Yes, it's a comet with a beautiful tail. So comets are just big lumps of dirty ice, basically. Ice with lots of dirt in it. And when they get close to the sun, the heat of the sun melts the ice, and there's this solar wind that blows these particles that hit the comet and blow particles off the comet. And they shine with this beautiful ethereal light. And that's what the tail is. That's this huge thing, far, far, far bigger than the Earth, just stretching out into space. And you can always tell where the sun is when you look at a comet, because the tail is always pointing away from the sun. We sometimes think that the tail follows the comet's motion, right? The comet moves and it leaves a tail behind. That's not actually how it works. It actually sort of is more like the hand of a clock going around the clock. The tail is always pointing away from the sun. And that was in 2007. Okay, what's our next one? What's that? It's a crater, that's obvious. Where? Where in the universe is that crater? Yeah, the colour gives it away, doesn't it? It's Mars. And look, it's full of ice. So if we ever get to go and build a station on Mars, we'll have water, because there's lots of ice. All you have to do is go out with your billy can, collect a bit of ice, bring it back in and heat it up, and you've got all the water you need. What's that? And it looks like it could be a nebula, but it's very dense. Yeah, it's actually a close-up of Jupiter. So in the last couple of decades, we've been able to send little probes to go around the planets of our solar system. All of you followed the Pluto one, didn't you? I hope none of you were too heartbroken when Pluto was demoted and is no longer a planet. Some people were just unconsolable. Not mentioning any names. I'm sorry, it's very bitter to talk about. But this is one of the probes that went to the largest planet in our solar system. And look at the beautiful little swirls. These are kind of weather systems in the gaseous atmosphere, the gas that makes up most of Jupiter. And it's really, really pretty. And if the clouds clear up, Jupiter is in a perfect position to look at with a telescope. And this is a little bit more like what you'll see in the telescope. You won't see any of that sort of detail. You can't really see that detail, I don't think, with any earthbound telescope. But what you will see is a circle, and if your eyes are really good, you'll see two lines going across it, and the moons around it as well. They're little bright dots. You all know this one. Okay, Saturn, yes, the Lord of the Rings. Isn't it beautiful? Saturn is not visible in the evening at the moment, so we won't be able to see it in a telescope. But when you do see it, it has the most beautiful colour. The colour in the telescope is more beautiful than this colour. It's one of those rare things. It's this lovely, gentle caramel colour. And then you have the rings around it, which are just incredible. You can see the rings are about as wide again as the whole planet, like they double the size of the system. And again, the Cassini probe has been out there lately, and I don't know if it's crashed already or it's about to crash into it. And it's been taking all these amazing photos, including these. These are some of the moons that go around Saturn. So the top two are the same moon, just from different angles. Doesn't it look like a lolly? Okay, that's the moon Pan. And then what does the bottom one on the right remind you of? Again, this is for the science fiction fans. The Death Star. Yes, of course, in Star Wars. So it's just because it's a little moon, but obviously something quite relatively big hit it and just made this huge crater that just dominates that whole section of the moon. But isn't that beautiful? What is that? Oh, okay, you all got that very easily. Yes, that's the sun. It's a coronal loop. So it's a loop of like particles that are very highly excited. And you can fit something like 5 or 6 planet Earths inside that one loop. That's how big it is. It's just huge. And yes, that's on our sun. What's that? This is a tricky one. It's an aurora, yes. Oh, well done. So you might say, but aren't we talking about space? Yeah, we are, but this is what happens when the waves of the solar wind hit the shores of the atmosphere of the Earth and they break. You know, when waves on the ocean sort of break and make all that foam and stuff, you can kind of think of the aurora as something like that, because what it does is it excites the particles in the atmosphere and they start to glow with this radioactive light. And they shimmer and they move over minutes and hours. And it's this really weird, otherworldly sort of thing. Quite amazing. And that's an open cluster. I think everybody will know. And this is the Pleiades. Remember that verse? Can you bind the cluster of the Pleiades or loose the belt of Orion? We saw the belt of Orion at the beginning, and this is the seven sisters. So there's a lot more than seven stars, but like count the seven brightest ones, and they're the seven sisters. And you'll notice there's something weird about them too, isn't there? There's a kind of an eerie blue glow. That's not your eyes playing tricks on you. That's because they're actually in a cloud of gas, a very faint, very wispy cloud of gas. And the light from each of the stars shines on the gas that's around it and makes it glow with that beautiful light. So I think there's a famous description of it as, what is it? Fireflies caught in a silver braid. Isn't that poetic? What's that? Well, it's called, you'll never guess. Does that remind you of the head of an animal? Yeah, it's called the Horsehead Nebula. Very imaginative. And it's a dark nebula. So the horse's head is actually a cloud of gas that isn't being illuminated by any stars, but it happens to sit in front of another cloud of gas behind it, which is being illuminated by stars. So the cloud behind it is that eerie red glow, and then the cloud in the front is like a silhouette. And so when it's like that, it's called a dark nebula. A nebula is just like a cloud of gas in space. And that's actually very close to the belt of Orion. What is that? Is that making you dizzy? Isn't it? It's sort of shimmering in my eyes. No, is that shimmering with you, or is that just my old eyes? Okay. Well, this is called the globular cluster. And again, if the clouds are kind to us, we can actually look at this in the telescope tonight. And basically what it is hundreds of thousands, I think this one is one of the bigger ones, so it might actually be millions of stars, all packed really tightly, closely together, like a huge ball, like a huge globule. And there is a theory that galaxies may begin as globular clusters and then gradually keep attracting more and more and more stars until they grow into galaxies. But we're not quite sure, I don't think, if that's the case or not. There's a really famous science fiction story by Isaac Asimov called Nightfall, where there are these people who live on a planet of a sun in a globular cluster. And so for them, there is no night. They never have night, because the stars are so close that they all look like suns. And then once every 2,500 years, by some strange twist of geometry, they actually have a night where everything goes dark. And so I don't want to spoil the story for you, but when that happens, like the whole civilization collapses and they go back to being cavemen, and then it takes them another 2,500 years to gradually build up civilization again, and then they have another night and they go back again to being cavemen. It's an interesting story. Okay. What's that? It's a spiral galaxy. Anyone know which one it is? Oh, it looks very similar to Andromeda, but it's actually a simulation of our Milky Way galaxy. So if we were able to rise way above the galaxy and look down on it that we are in, that is what it would look like. And just in case you get lost, that's where we are. Okay, so for all of its beauty and its glory, I've tried to give you a little bit of a taste of how beautiful and wonderful the universe is that's out there. And it makes us feel how big it is in both time and space, and therefore how big and majestic is the God who created all of this. To me, I think we are very blessed to live in this time, because in ancient times their view of the universe was relatively tiny, and so their view of God must have been relatively tiny. And I think in modern times we have the opportunity to just realize how huge and big and amazing God is. But there are some nice little holy heavenly sites. So these are a little bit of fun, probably not to be taken too seriously, but did you know that there are 3 Copts on the moon? I bet you didn't know that. But there are actually 3 Copts on the moon, and you're looking at 2 of them in that picture. You see the 2 big craters towards the right-hand side of the picture? Their names are Kyrillos and Theophilus, and they are actually named after Pope Kyrillos, the pillar of faith, the Pope of Alexandria, and Pope Theophilus, his uncle, who was also the Pope of Alexandria. And the third one, down the bottom there, is Katerina, and that's named after St. Catherine, after whom is named St. Catherine's Monastery in Sinai, which is also part of Egypt. So we're claiming all 3 of those. Right, so there are 3 Copts on the moon. Every time we look up at the moon, you have some friends up there. And again, this is where you find them. So I always think of the moon as a rabbit. I don't know if you use the same system, but that's the rabbit's head, and they're the 2 rabbit ears, and the rabbit's like upper chest, and that's the rabbit's body. So you just look for the rabbit ears and the head, and there they are there. You can't really see them with your eyes, but you know, with binoculars you can just about see them. Can anyone recognize the constellation? Sorry, I've got the name there. I didn't realize. So this is the Southern Cross. So here is a nice little contemplation about the Southern Cross. Here is a Southern Cross itself, right? The 4 stars are very well known. They're on our flag and everything, okay? Next to the Southern Cross, and they're the pointers. They call them the pointers, and we're going to find out why they're called the pointers in a second. But next to the Southern Cross, just under the EL of jewel box there's this little star cluster that I was talking about before with all the different coloured stars. So you have a jewel box, and then you notice the black part, the black area under it, and that's called the coal sack. So here is our little contemplation. Jesus is on the cross, right? And he is like the jewels. He and St. Mary and St. John are the jewels that are sitting on top of the sack of the black sins of humanity. And what he's doing is he's saving us from those sins by trampling upon the Lord of the Flies, right? Because the constellation right beneath the Southern Cross is called the Fly, Musca, the fly. And one of the names of the devil is Beelzebub, which means the Lord of the Flies. So when you look at the Southern Cross, you can have this lovely contemplation of how Jesus trampled upon the Lord of the Flies in the constellation of the Fly in order to save us from our sins, represented by the coal sack, which is black and dark, and thus gave us the precious jewels of salvation, which is the jewel box cluster. I know I'm stretching things a little bit, but here is why they're called the pointers. If you take a perpendicular line that goes right through the middle of the pointers, and you extend that line as far as you can, and if you take the vertical of the Southern Cross and extend that line as far as you can, where they meet, so if you get your finger and you point to the point where they would meet, you are pointing south. You are pointing due south. So if you're ever lost in the bush and you don't have a compass and your smartphone doesn't have reception or GPS, then that's how you can find south. You can work out south. You extend those 2 lines, and the point where they meet, you point there, and that is due south. This is one of my favourite pictures. They call it the pillars of creation. And it actually is, because the bright bits at the tips of those clouds are actually nurseries where new stars are being formed. And as they sort of become stars, they start to burst into light. And that's that glow that you get at the top of those columns. So they actually are pillars of creation. It's I'm sure you've seen that picture before. People use it everywhere. If you went to a Coptic school and did Coptic Orthodox studies, it's on the cover of one of the textbooks. And there's a Christmas tree. Isn't that nice? This is called the Christmas tree cluster. Can you see the Christmas tree? We're kind of joining the dots here. You know, this is pattern recognition. If you can't see it, this should help you a little bit. Okay. See how the lovely Christmas tree has Christmas lights everywhere, right? And it's all, shining and twinkling, just like a Christmas tree should. But then at the top of the Christmas tree, this is called the Cone Nebula. And there is something very Christmassy about it. If we enlarge that and turn it upside down, it looks like this. Does that remind you of anything? Can you see something iconic there? Shall I help you? Anyone see it yet? No? Yay, someone got it. Okay, so here is St. Mary. That's her face. That's her veil. That's her shoulders. And there's Jesus. That's the head of Jesus and his little arm reaching up to St. Mary. Right? And they're sitting on some kind of a rock or something. I don't know what they're sitting on. Okay. Can you see that now? Does it look a bit like St. Mary carrying Jesus? And the interesting thing is, notice how there's this bright light on her head. It's like a halo, right? And the head of Jesus is very bright. And interestingly, in Orthodox icons, have you ever noticed that there are stars? There's a star here and a star there, and on some icons there's another star on the other side. Can you see the stars? Right? And interestingly, here is like a bright star up top, and there's a star down there, and there's a star there. So when you look at the heavens, you even find St. Mary there. As I said at the beginning of this section, don't take this too seriously. I'm not saying that God did a miracle and created an image of St. Mary. As you know, it took a lot of you time to sort of get it, and that's just our brains finding the patterns. But I like it. I think it's kind of like God knew how our brains were going to work, so he kind of left us little fingerprints to tell us that he made this universe. And we've just got one left. This is a real picture of the centre of the Whirlpool galaxy, which is in that top left corner there, a spiral galaxy. And then the Hubble telescope took this really, really high resolution picture of the big black hole at its centre. And what does that look like? It looks like a cross. So apparently what it actually is this huge kind of donut of dark gas that surrounds the black hole. That's the vertical part of it. And then somewhere, they're not quite sure where, there's another kind of big cloud of gas that crosses it. And from our angle, when we look at it, it just looks like a cross surrounded by light. And it's at the centre of a galaxy. And I think that's just a beautiful symbol of how the cross is the centre of our lives, the centre of our universe, and always should be the centre of our universe. Okay, that's it. We've come to the end. And so we'll just finish with, remember I said to you that you find the heavens in the liturgy? Well, this is one of the places where you find it, from the liturgy of St. Basil, that God is the one who created the heavens, the earth, the sea, and all that is therein. And when I get to that bit of the liturgy, I always want to stop at the word the heavens and think about some of this amazing, complex, huge universe that we're in. But if I did that, you'd all get very upset, or maybe think I'd fallen asleep or something like that. So I don't. But one day I might do it. And if I do, you'll know why. Glory to God forevermore. Amen. Okay. So, do we have time for questions or things, or have we gone over time? I wasn't looking at the clock. Oh, we've gone way over time. That'd be good. Sorry? We can take questions. Does anyone have any questions? I'll stand up to see if I can see you. Look in the dark. No? Yes, oh sorry, I can't see you in the back there. I would say there's nothing in our faith to discount the possibility. Like, if it's discovered that there are aliens, why not? God, as we saw, God made this amazingly huge, complex universe. It's quite possible that he may have made other living things in other places in the universe. That would only add to the beauty of what he's created. Then you get really interesting questions like, did they need salvation? Did they fall or not? And things like that. And I don't know the answers to those. If we ever do, I hope I live to meet aliens and talk to them. I would so love that, having been a science fiction fan most of my life. And that's one of the things I'd like to explore, like what is their view of sin and what is their view of God and things like that. I think that'd be really fascinating and interesting. There was a time when Europeans thought that they were the only humans on the earth, and then they found like Africans and things, and they thought that they weren't even human. And, you know, it kind of shook their universe and shook their world and so on. But nowadays we look at that and say, why? You know, what's the big problem? What's the big deal? I imagine people in 1,000 years, if we find aliens, they'll probably say, why were those people so worried about aliens? Who cares? But I think that, like, just scientifically speaking, from what I understand, the probability of there being aliens out there is really, really high. The probability that we would ever come into contact with them is really, really low, because the universe is so big, right? So we don't know where to look. We don't know how to look. And for them, and then you've also got this whole thing about civilizations seem to, you know, progress very quickly. So aliens are, if there are aliens out there, they're very likely either to be so primitive that we wouldn't know about them, or so advanced that they wouldn't care about us. We'd be like ants to them. You know, who wants to talk to an ant, right? That's just boring. So, like, for two civilizations to make contact, they have to be roughly the same level of development, kind of thing. And because the universe is like very old in time, the chances of two of them matching up and matching up in space as well is very, very tiny. So sadly, it's unlikely that in our lifetime or, you know, in the foreseeable future we will make contact with aliens. But that doesn't mean they're not there. And again, that's a humbling thought, that we think that we control everything in our world, but actually there's a lot of stuff we don't control and have no control at all over. That's good for us to be humble. Any other thoughts or questions? Yeah? Oh, we have one, and then we'll come back to you. Okay, that's a really interesting question. It seems, okay, when we look out at the universe, there's a limit to how far we can see. So from our point of view, it looks like the universe is like a big ball because of that limit, and we seem to be at the center of it. But it's more likely to be something like this. If you're a point on the edge of a circle, where are you on the circle? Right? Everywhere you look, there is going to be a limit, because sooner or later, what you're seeing in that direction around the circle is going to match up with what you're seeing around that. So are you in the center of the circle? You're not really, you're just on the point. If you think of the universe as being a four-dimensional rather than a three-dimensional thing that is bent in the fourth dimension, so if we were on the edge of that, like if we were a point on that sphere, every direction you look seems to have a limit, and you look like you're in the center, but you're not actually in the center. Everybody sees the same thing wherever they are on the edge of the sphere. So I think that's how we understand it, that it looks like we're in the middle of the universe, but we're probably not, because even if you were what we see as the end of the universe, for them, we look like the end of the universe. And they feel that they're at the center of the universe. So, yeah, I don't think you can get the idea of the shape of the universe by thinking in 3 dimensions. You have to kind of think in a 4th dimension, which we can't. We can only theoretically talk about it, but we can't imagine it or sense it. Yeah. But yeah, if it makes you feel better to feel that you're in the center of the universe, then yeah, that's how it looks from where we are. Sorry, I'm gonna. Yeah. We can get away with that with God. We can say that God has no beginning, has no need to be created, because God is like transcendent. He's not like anything that we know in this universe. We can't get away with it with the universe because we're in the universe and we can see what the universe is like. And we can see that, for example, everything in the universe has a cause. Nothing happens without a cause. So the nature of the universe that we can see says that everything has a cause. When you talk about God, he's outside of the universe, that rule doesn't apply. If everything in the universe has a cause, then it can't cause itself, because the nature of it stops it from being its own cause. I don't know, have I lost you? Probably. I suppose what I'm trying to say is there is a difference between what the universe could do and what God could do, the way that we know stuff about the universe, and that puts limits on what the universe can do, and that includes that it can't bring itself into existence because everything has a cause in the universe. When we speak about God, you don't have those limits on him, like those rules don't apply anymore. So he can answer that question of being something that does not have a cause. He himself is then able to be the cause of the universe, whether it's eternal or whether it has a beginning. In that question, it doesn't really matter. Sorry, I've confused you probably even more. I have to think about a clearer way to, to say that one. Sorry, yep. Yeah, that's a really good question. I don't really know, I can't understand the answer to that. I've asked that actually of physicists, and they've explained it to me, and at the time they explained it, I thought I got it, and 5 minutes later I realised I hadn't. Okay, so this is the best I can do, okay? It's not expanding into anything. And it's not, okay, so don't think of it as there is this space which is like static, like a grid, and then stuff is moving away against the background of that grid. Okay, that's not what it's like. What you need to think about is the grid itself is being stretched. Space itself is being stretched. I know, that's where I say, no, it doesn't make sense. So, I don't know, that's the best that I can give you. Mark, yes. Are you answering this question? Yeah. I know, right? That is my question as well. That is actually exactly the question I once asked to a guy. Okay, because the way we know it's expanding is because of that redshift, right? Because the waves of light coming towards us from distant objects are further and further apart. And that's supposed to be because the universe is being stretched, space is being stretched in between. But then my question is, if space is being stretched, then the distance between each wavelength is also being stretched. So you shouldn't notice a redshift, but apparently you do. And apparently it has something to do with the speed of light being constant and things like that. I'm not sure. This is where, again, 5 minutes later, it just didn't make any more sense to me. One day we should get like an astrophysicist to come to church and we can ply them with all these questions. We should do that one day. Alrighty. Okay, I think we'll call it quits there. Oh, you can do the announcements and then we'll pray at the end. Actually, while you're announcing, just quickly see if they're at the house. Okay. All right. Just